Bueno, esperamos que lo estén pasando bien. Y ahora hasta aquí han llegado las ponencias de hoy, nuestras charlas. Ahora és moment d'obrir la taula rodona on tots vostès van a tindre la possibilitat de preguntar i debatre directament amb els tres convidats d'honor que tenim avui així amb tots nosaltres. Però no seré jo qui l'obriga. L'encarregat d'obrir la taula rodona és Vicent Botti, el vicerrector de Tecnologies de la Informació i les Comunicacions en la UPV. Vicent Botti és catedràtic d'Universitat de l'àrea de Llenguatges i Sistemes Informàtics en la Universitat Politècnica de València, on és professor des de l'any 1984. A més, Botti és director del grup d'investigació de Tecnologia Informàtica i Intel·ligència Artificial i del Microcluster Social and Economic Computing del Campus Internacional d'Excel·lència València Campus. Amb més de 30 anys d'experiència, és Premi d'Investigació de l'Associació Espanyola per a la Intel·ligència Artificial i del Consell Social de la UPV i membre emèrit de la European Association for Multi-Agent Systems. Professor Vicent Botti, un plaer.
Moltes gràcies, Maria Jesús. Bona nit, benvinguts tots a esta taula redona. I durant els pròxims 25 minuts tindrem l'oportunitat de poder debatir sobre el progrés, els riscs i les oportunitats de la intel·ligència artificial, sobre com les tècniques d'intel·ligència artificial són utilitzades en els robots humanoides i sobre els models de negoci de les aplicacions de la IA. Per això tenim l'oportunitat de poder comptar amb la presència de tres ponents de luxe que ja han presentat en les seues xerrades prèvies la seva opinió sobre aquests temes. Poder comptar amb el professor Tom Dietterich és un immens plaer. Tom, welcome to Valencia and thank you very much for the opportunity to share with you this time. The work of Tom is focused on machine learning, mainly in data science and big data. And he's looking for solutions that allow to computer systems to adapt and learn from their experience, to combine machine learning with other advances, and to allow to artificial intelligence to build integrated intelligence system, and to combine human knowledge with massive data sets to build more useful computer applications. También es un placer poder contar con Enrique. No es la primera vez que está aquí en Valencia a través de Francisco. Pues Enrique se define como periodista, es profesor de sistemas de información en la E-Business School. Su trayectoria es también peculiar, ¿no? Pues que empezó su andadura con una licenciatura en Ciencias Biológicas, continuó con un máster en el Instituto de Empresa y acabó doctorándose en Sistemas de Información en UCLA. Es colaborador habitual en numerosos periódicos y revistas en temas relacionados con Internet y las nuevas tecnologías. Y su blog está considerado como uno de los mejores blogs en castellano, yo creo que también en inglés. Principalmente su trabajo se centra en estudiar los efectos de la tecnología sobre las personas, las empresas y la sociedad en su conjunto. Y por último, pero no menos importante, qué decir de Ramón, ¿no? de Ramón López de Mántaras. Ante todo, decir que Ramón es amigo, ¿no? Nos conocemos desde hace más de 25 años. He tenido la suerte de poder colaborar con él en distintos proyectos en los que hemos participado en mi grupo con el Instituto de Inteligencia Artificial del CSIC. Pero Ramón es una de las primeras personas que trabajó en inteligencia artificial en España, podríamos decir, utilizando el tópico, ¿no? Que es uno de los padres de la inteligencia artificial en España. Pero no solo en España, yo creo que también en Europa. Ramón es reconocido a nivel internacional como una de las personas con mayor reputación en el área de la inteligencia artificial. Y como prueba de ello tenemos datos, ¿no? Como es su Premio Nacional en Informática, que recibió en el año 2012, o el premio también Robert S. Engelmour, que recibió de la Asociación Americana para la Inteligencia Artificial en el 2011, los cargos que ha desempeñado en diversas entidades y asociaciones científicas, tanto nacionales como internacionales, su representación en la International Joint Conference on Artificial Intelligence y en la European Conference on Artificial Intelligence, y también por sus trabajos en reconocimiento de formas, razonamiento basado en casos y por una cosa que a mí siempre me ha gustado mucho de Ramón, ¿no? Por sus aplicaciones de la inteligencia artificial en la música. Jo crec que és una oportunitat molt gran poder comptar en estos tres magnífics ponents i que segur que el debat serà molt interessant. Li dono la paraula a Can, no? Que va ser el moderador d'este debat. Hello, Bacan.
Thanks a lot. Okay, so let's have our roundtable participants here. So I've been watching all the presentations as you have. My name is Atakan Cetinsoy. I'm with BigML, and I'm in charge of product marketing and product management at BigML. And as part of my job, of course, I follow the machine learning space pretty closely, which is challenging because there's something new and new applications of machine learning every day. And yeah, that's good. Doesn't matter. Okay. All right, thank you. Okay. And this series of presentations definitely was of great interest to me. And I think there's been a lot of interesting insights shared by some of the most accomplished profiles in the industry. So we're lucky to have them for another 25 minutes or so to pick their brains. One thing, although I'm not much of a Spanish speaker, and my Skype real-time translator crashed midway through. Too bad. One thing I picked up on was that there was this little boy holding a toothbrush, which was mislabeled as a boy holding a baseball bat, right? But in the following presentation, there was a boy that looked suspiciously like a grown-up version of that guy holding a baseball bat, which made me think that maybe the strong AI is already here. It's just hiding behind the scenes. And, you know, you never know what happens next. So talking about what happens next, one of the areas that machine learning is being applied, in addition to varied fields like sports or politics, is you know, the current presidential race. And it seems that Donald Trump is leading the polls at this point, which makes me think if the strong AI is here, it better show up fast because we're about to mess up the whole planet, right? So in any case, turning our attention to the panel here, the idea is to start it off with a couple of questions and then turn it to the audience. Maybe I thought it was best to start to maybe delve into the technology and how it's going to evolve a little bit. I was recently reading the book by Pedro Domingo talking about the master algorithm. And in his book, he's making a good case for an algorithm such as a Markov logic network sitting on top of other known methods, acting as this all-purpose generalizing engine, if you will. So in your opinion, Professor Dietterich, is this a research direction that will be further explored? And are we going to see more of a search for, in a way, the theory of everything for machine learning in the near future?
Well, I actually worked on a system that was trying to use Markov logic to connect together different learning systems. In this Kalo project that was the predecessor of Siri, we had machine learning tools that were trying to tag a document or an email message with various kinds of tags, and different. If we were part of a work group, I would tag a document, then maybe send it to you, and you might send it to him. And the question was, how you had your tagger that you were teaching. I had my tagger. How could my tagger learn from your tagger in some way that we could? And so we used Markov logic to write rules that would say things like, our taggers should agree with each other when they can, and things like this. Or the tag on an email message should match the tag on a document that's attached to the email message, things like this. And so we worked out how to try to do this kind of end-to-end learning. The idea is that when Ramón gets the message, he changes a tag, and somehow that tracks back all the way to my system and improves my system. So it's kind of like social tagging, I guess, propagating through this network that we have. So I do think that's the kind of thing. There are some challenges, though, that have been pointed out. I'm blocking on his name. Léon Bottou gave a speech at ICML, the Machine Learning Conference this year, and he talked about a problem that I think may have occurred in one of the companies he worked with. So there were two different teams, both trying to use machine learning, not aware of each other. One team was trying to do A/B testing, presenting different alternative advertisements that were going to be shown to website visitors. Another team was trying to decide what font size to use to render the ads. They were going to take the ones that they predicted the users would want and render them in a big font, and maybe the ones that were less likely in a smaller font. And so what would happen was the A/B testers, they would put up a message as an experiment an advertisement as an experiment that they thought, maybe the user will click on this, but maybe not. The font guys would render it in a very small font because they predicted the user will not click on it, and the user does not click on it. And this confirms the predictions of both groups. They're both completely happy. They're both doing their testing properly with separate test data from the training data, and yet they clobbered each other's experiments, destroyed each other's experiments. Mm-hmm. So this is the problem that we need. I guess it's another argument for Pedro's point that there needs to be a level of the architecture that knows about the different learning components and can coordinate them. Otherwise, bad things will happen like that.
So it's more complex than it sounds in the first place, I suppose.
Yeah.
Great. So let us continue with Professor Ramón López of Mántaras. So one of the jokes in the Bay Area, which is where I live, is that the data scientist is a statistician that knows how to code and happens to live in San Francisco. So that's sort of the ongoing joke. And the concept itself, data scientist, is a fairly new one. And a lot of companies are racing with one another, LinkedIn, Google, Facebook, trying to, in a way, wage war against their competitors to secure the services of these people that are highly qualified. How do you see the data scientist job itself evolving and changing and becoming the force behind bringing some of these new techniques to industry and to government and nonprofits?
Well, the main problem with data scientists is the shortage of data scientists, right? I mean, we are continuously getting, I'm getting very often mails of colleagues from all over the world saying, do you know of anyone that we need to hire, data scientists? I think nowadays the data scientists are not only from computer science departments. I think many of these companies are fishing data scientists, besides stealing scientists from other companies, they are looking also for people that are done studying mathematics, for example, and applied mathematics in particular, statistics. People who are used to that, they have very knowledgeable of statistical tools and very knowledgeable about, they have to be able also to be able to model, to approach a problem and know what is modeling a difficult problem. And I think that in terms of the computer science faculty and departments and people like us who are in computer science, more in the computer science field, we are witnessing this issue of that the future of this data science will be more and more from outside the computer science field. It's maybe we should also somehow train our computer science students more focusing on this data science. Now, that's like any other, that's a real need, but all this data science, there is also some sort of a hype, and what now we call data science, maybe in the future we will call something completely different, and we have to train our students and our young people that want to do to work on these techniques on this field. To have a more broader training. I think getting also ideas and inspiration from other fields is also important. There are many work on let's say on mathematical modeling of complex systems that can be used also for data science. Maybe we are too much focused on some the tools that I have. I have a hammer and everything looks like a nail. That's maybe a danger also for the future of data scientists. So maybe we should have a more broader and interdisciplinary training of our young people to get ready for future demand, for future,
Yeah. For example, I think very often tools from economics are needed.
Yes.
And game theory has already been brought in some, but clearly a lot of these questions with where like advertisement placing, ad placement is a huge thing, and this is a game between the different advertisers and between the search engine company and the advertisers, between the user and the company, especially with ad blocking, and so how you. If you treat that naively as a machine learning problem that's a purely prediction problem, you will not do well because it's really more adversarial.
Yeah.
And one of the things that Pedro Domingos also pioneered was this idea of adversarial machine learning, where you make a prediction, but your opponent is trying to always defeat it.
I have two interesting elements in the masters we have in IE, in big data machine learning. We had last year was the first year we did it, and we launched it. We had 15 people. It's pretty normal for a master's that starts and to have a small number of people from all over the place, but 15. This year we have 55 after an important selection process and all that. And the other interesting element is that now in the international MBA we have a lot of people that used to. It used to be that when someone could code or could or be understand statistics or strong quantitative skills, they were coming to an MBA to avoid using it later on. Now it's not like that anymore. Now they don't hide that line in their resume, and they display it very proudly. So you can see that there's a strong bias in the market towards that.
That's great. So I think as a continuation of that, maybe for you, since you're teaching MBAs, in my point of view, the application of technology is important. The algorithms, how you create a data pipeline to fill the algorithms, all of that. But I think one of the challenges is actually a management mind shift, right? So a lot of people are talking about data-driven decision making, but in reality, companies are still, I think, struggling to really get there, right? So in a very information-rich and intelligent environment, how do you think the management science itself or the management discipline itself will have to adapt, right?
It's a big problem. The problem is that we still perceive management as a soft science, as something that deals with, let's say, states of mind or opinion or visions. When someone is a very good manager, we call him or her visionary. Hey, it's not a matter of vision. It's a matter of analyzing. It's more of a hard science. It's becoming more of a hard science. So we need to get these MBAs into really understanding that now making decisions is something that goes with deep analytics, data, as much data as you can, and truly a different mindset. So and it's becoming, it's changing the way we analyze cases. It's changing the way we ask for assignments. Now assignments used to be strongly opinionated. Now it's not that much like that. The cases are different. I don't use that many cases these days. I try to use things that are happening in real time and at least get them to propose the type of analytics that they would need, they would require. In my ideal world, they will start having those tools ready for during their education. So when they finish, they will have the toolbox ready to use in any situation.
That's great. I think it's going to turn into more of a "in God we trust, all else bring AI" kind of thing, right? Okay.
Absolutely.
All right. So I want to be conscious of time here, since we're limited. And I want to open it up to questions from the audience at this point. I think we have a microphone. And if possible, please ask your question in English. Otherwise, we'll try and translate, I guess, for everyone.
Let me remind all of you that everyone asking questions will get a BigML t-shirt for free.
We had a bit more light a moment ago, and I could see them. Now,
Cannot see.
It's dark again. I cannot.
We cannot see.
Can we put a little? Turn on the lights, because otherwise it's like.
I have a question about business development in the field. Thinking about small enterprises, there is a problem that I see, and is that being an emerging field, there is a component in research in terms of coming up with business ideas. And very small enterprises are not into research because economic reasons prevent them from doing research. So my question is, has there been any work done in terms of thinking what would be an ecosystem for this field in terms of typical business models for small enterprises to be able to participate in this dynamic field?
My understanding is that in terms of barriers of entry, we are really going down. I mean, we are building better and better tools that can be used in a simple way. I mean, I can see myself, I'm no expert in machine learning, but I can see myself doing things with some of the tools. I mean, it's the same revolution I lived through when I saw the spreadsheets back in the 90s, early 90s, when people were, the average manager could not understand a spreadsheet. Now we see spreadsheets and they are like this, come on, coordinate system, numbers, operations, that everyone can use it, okay? But now it looks a little bit like the same feeling. I mean, the tools used to be extremely complex, and now, hey, I can do stuff. So any person with so now the limiting factor is not the tool, it's being able to generate data. If you're able to generate data, chances are you will find a tool that is easy to use, probably not so expensive, where you can start making decisions and understanding what's going on. I don't know if that's your perception, that I see barriers of entry going down.
Well, that is the entire goal of BigML.
Yeah,
right?
exactly.
So, yeah, exactly.
Yeah.
Okay, other questions? Someone in the back?
Still, most computational burden in machine learning lies on big systems. So we still do a lot of things just by brute force. So in one hand, it creates a technological disparity when the giants like Google, like Microsoft, they naturally have more processing power, while single users like students, they are limited. But still, with great power comes great responsibility, like movies teach us. Don't you think that in one moment we have to regulate, let's say, set the limit of maximum processing power allowed for non-governmental bodies, like we regulate uranium or other potentially dangerous technologies?
Oh, I think that would be a mistake. If you look at I mean, you're certainly right that a lot of the work in computer vision, for example, was first done at Google, and for speech recognition, actually, Microsoft Asia, because they had huge resources available. But now, for instance, the deep neural network technology has been ported to graphics chips. And so you can train a deep neural network on a standard workstation with graphics cards added and really achieve state-of-the-art performance if you have the data. So again, it's really the data that is the limiting factor there. I think I may be repeating myself, but one of the other goals of BigML is to make it very easy to run on the Amazon cloud. So it automatically will spread out your data across many servers. So this is another, this kind of machine learning as a service is another way of really packaging that that big computing resource into something that is very easy to use. Really, the user experience is the same whether you have a small data set or an immense data set, because the infrastructure takes care of the scaling.
I would say there's a problem with the typical European versus US mentality. In Europe, we tend to pre-regulate things. Hey, let's regulate this just in case there are problems. In the US, they tackle the problems as they happen. So, okay, first let's allow things to happen, and if there's a problem, we'll try to regulate it, or we'll try to stop it somehow. But here in Europe, we are constantly trying to anticipate the problems, and that's a limiting view, I think. So,
well, but on the privacy side,
yep.
Europe is more a leader than the US, and the thing about privacy is once it's lost, it's lost. So
I'm not sure if Europe is a leader in privacy, or if we just didn't have a Snowden coming up with...
This is also possible, yes. Yeah.
Privacy is lost, basically.
Yeah.
Okay. Okay, any other questions? Maybe we have one more.
Okay. First of all, let me make a joke from the last talk. Maybe here? Okay. About the red car perception, maybe it will be because you are looking from information on the web, and some kind of recommendation system put only information about you have a red car, something like that. So, and so moving on. In the last day, we have the safe harbor discussion on the EU court, and I want some reflection from you, from point of view, from an economical point of view. I think that this will improve the start of a new and old company here in Europe, and that you have to store data here in Europe with the European policy and so on. And maybe with this, that we don't have to put the data in the US country. This will help from the second point of view from Ramón about trusting less the data and think more about the structure to integrate different part of artificial intelligence problem and create this new abstraction structure like the Markov logic. You get the meaning what I'm...
There was a question for you first, right?
For me. Oh,
yeah,
the first question was for
Sorry,
him, right?
I didn't get the question.
The question is, with the safe harbor, we have to store the data here in Europe. Mm-hmm. So we have to apply different policy on the data processing than before. Before you store here for a fixed amount of time and then put on USA. But this is proven that NSA can use profiling on your profile. And because we have a European regulation about privacy and so on, we have to start here. So this will improve a lot of company. This is my idea. But what is your idea about the economical impact and also the social impact of this outsourcing? And then the second one, it's about the different approach from big data thinking, and one about more structural abstraction logic of this.
I think it will be, the safe harbor thing, it will be an opportunity for many European companies to adapt and try to bring solutions to European companies who now cannot or don't want to export their data to the US. But on the other hand, it's a bit artificial. As I was saying, I'm not sure if there's a real problem, a real issue going on, or if there are just things that we don't know that are happening here. But probably my perception is that the problems we are facing in the US, at least in the US, at some point I can get to understand what happened. At some point the data get public exposure, etc. Here, I'm not sure. As a European, I'm not that sure that this is actually happening. So I don't know to what extent is this answering a real problem or not. And I need some more time to see how the issue is going to evolve right now. Whether is this going to turn into a problem for European companies or a limitation, or maybe an opportunity for others. I really don't know.
One business proposal would be safe harbor as a service.
Yep.
So that small companies could comply with safe harbor and still effectively combine data across the Atlantic.
Yeah, on the other hand, it's from an economic viewpoint, the more I can distribute in different data centers, the more, I mean, the better.
Yes.
The more I can follow the moon, the more I can. I see it as,
Yes.
as a bit artificial.
Yeah.
Okay, one last word maybe?
Yeah, I think there was this another question about the massive data-driven AI, right? And in relation with these isolated or integrated systems, if I understood well.
If we have to apply this safe harbor discussion in the EU and we don't have the opportunity to ship the data from US, probably the company that have to rethink about the model to process and so on, maybe will be a little, the machine learning will be a little bit less data driven and more thinking about the structure to integrate, to think, more logical reasoning than simple statistical inference and so on.
Yeah.
What do you think?
Well, yeah. Of course, to do massive data-driven AI, you have to have massive data. It's true that not everyone has easy access to massive amounts of data to do, not only to do applications, but from a more academic point of view, to do research on improving, for example, what the so-called deep learning algorithms and other kind of AI techniques that are rely on this availability of massive data. Now, it's true that perhaps because of the cake, the big piece of the cake is already taken, let's say, by this very large company that have all this data. Google obviously is an obvious example, but not the only one. I think you mentioned basically a lot of them in your talk. These are small companies that you were saying. These are small companies. Maybe from the academic perspective, what we should do is to try to find a niche, and you want to contribute to AI. Yeah, that's true. That maybe an opportunity to focus on other approaches to AI, which don't need so much this availability of this massive data, and try to focus on this, what I was telling in my presentation, thinking about this in architecture that integrate all these components of what is supposed to be the intelligence, right? Reasoning, learning, etc. And there is much work to do there. So there are much research opportunities, scientific opportunities on questions that have to be answered. But this doesn't go against the massive data thing. I mean, at some point, I'm sure that the massive data-driven AI can benefit from progress on this other research on AI and incorporate them, like the explainability thing that I was mentioning. The explainability, looking for ways of adding explainability capabilities to all these deep learning, for example, algorithms. Maybe, I think the progress can come from research that a smaller group that doesn't have lots of data but has good ideas about how to add explainability capabilities to these systems can contribute to the overall picture.
Yeah, thank you for that answer. Sorry, we have to wrap it up. I want to thank all our roundtable participants here, and if you have additional questions, you can definitely catch them outside during the cocktail period. Now I think we're going to have some announcements. Thank you again for the great questions.